Hello, everybody. Today we're going to talk about right triangles. And before anybody asks, no, there is not a wrong triangle. There are only, well, there are different types of triangles, but one of those types is not wrong. So, all triangles have three sides. We all had learned that at a very young age. If not, I'll teach you now. They have three sides. And right triangles have exactly one right angle. And then you'll say, but what's a right angle, Ruby? Well, I'm going to tell you. A right angle equals 90 degrees. It is a perfect corner. Okay, so an example here of a triangle is right in front of you. It has a right triangle. It has a 90-degree angle. So that indeed is a right triangle. Now, if you have something like this that looks like an equilateral triangle where all the sides are the same, nope, none of those angles are 90. Then if you have a triangle that ate too much for dinner like I often do, no 90-degree angles there either. So that is not a right triangle. This is an example of a right triangle. This square in the bottom is what you're looking for, or in the top, depending on where it is, but that means 90 degrees. Okay, so let's go on to the next page. The sides of a right triangle have very specific names. We have the legs. They are the two shorter sides, okay, of a right triangle. They meet at the vertex of the right angle, and I'll show you what that is. They meet at the vertex of a right angle. So right here, I see that I have a 90-degree angle. So this would be my leg, and this would be my leg, and this is my vertex, okay? We use the letters A and B to label the legs, all right? Now, the hypotenuse, such a fun word to say, the longest side of a right triangle. It is opposite of the right angle. So we use the letter C to label the hypotenuse. So let's come down here and see if we can get these labeled. I see a 90-degree angle here. Can't assume it, only if it's marked is at 90. So that is 90 degrees. So that means we have two legs. This is leg A. The legs really don't matter. Either one could be leg A and either one could be leg B, but I'm just going to do that. And then directly across from here, pretend this is an arrow. Okay, I'm going to pretend it's an arrow. I'm going to make it an arrow. And it is pointing across to there. That is side C. And that is your hypotenuse, which I am going to abbreviate. I'm going to make shorter. So down here is our right angle. So again, this is my leg. Call it A. This is another leg. Call it B. They formed, the two legs formed this right angle. This is the vertex. And then across is side C, which is the hypotenuse, and it's always the longest. It is very important to understand that the hypotenuse is always the longest, okay? All right, so let's go on to our next page, and I'm going to use a little bit of assistance to help me say this, okay? So let me move down here. Aha. Hold on, let me get my phone ready. We are now going to talk about the
Pythagorean theorem.
Very good, because
Pythagorean theorem
states that the sum of the squares of each of the legs is of a right triangle is equal to the square of the hypotenuse. So let me make that a little bit easier, because I rarely say that word because I always get it wrong. So I just call it the P theorem, so you will hear that from me. And basically, it's telling us something that is not as hard as we think it's going to be to understand. It sounds complicated, but it is not that difficult. What it's saying is that the sum, so I'm going to sum means plus, of the squares of each leg, well, our legs are A and B, and now we're going to square them, is equal to the square of the hypotenuse. Well, hypotenuse is C, and we're going to square it. So again, if you just take what they say to you, the sum of the squares of each of the legs, like that is one part, which we did here, of a right triangle is equal to, well, that's right there. The square of the hypotenuse, that was our third piece, is right there. So if you remember to read carefully and break things down into little pieces, you can remember, or you can figure things out like that as well. All right, let's go on to the next page. Or it's the same page for you, next page for me. We have an example here, okay? And we're going to prove that this triangle here is a right triangle. Well, the only way to prove that is to make sure that a squared plus b squared equals c squared. Okay, that has to be the situation for this to work. So let's come over here and we're going to label these, okay? Let's call this A. All right, let's call this B, and across from the right angle is C. Okay, so my first leg, A. If you look, the length of A is 1, 2, 3. So we're going to call it 3 squared. And the length of B is 1, 2, 3, 4. So we're going to call that 4 squared equals. And then let's go ahead and count this and see if it's going to work out. 1, 2, 3, 4, 5. Is that going to be equal to 5 squared? Well, let's find that out. Using your calculator, 3 times 3, or 3 squared, is 9. And then using your calculator again, 4 squared, or 4 times 4, is 16. And let's see what 5 squared gives us. 5 squared definitely gives us 25. Now, let's take this one step further. If you add 9 and 16, you get 25. So it's true. A squared plus b squared, each of the legs squared, equals the hypotenuse squared. If you add those squares of the two legs together, you're going to get the hypotenuse squared. All right? I promise you that this is going to get easier, but this is something that's going to be very helpful throughout your life. So stick around.